They'll be adults by the time the Pacific swamps the 9 sandy studs that are the islands of Tuvalu. If forecasts are correct, the seas round here will rise by about 2 feet over the next 50 years.
It's not only the media. The scientists themselves are not averse to making the situation appear dramatic. Steve Schneider is one of the United States' leading global warming theorists.
If the sea level rises, and those projections range anywhere from a few tens of centimeters to maybe a meter or so in the next 100 years, that by itself is not that serious except to places that are low-lying, the Maldives and Venice and probably London. But what really is serious is if the warming of the oceans causes an increase in the energy source for severe storms, then you get a higher probability of more intense hurricanes or other severe storms driven by ocean evaporation.
That's particularly important in a country like Bangladesh, where there are tropical cyclones that even today kill many thousands of people. In some parts of the world, I think there's very strong reason to believe that the consequences would be severe.
But as with temperature changes, the facts about sea level rise tell a different story. The Oceanic Institute near Cape Cod, 250 miles north of Manhattan, is one of the most influential organizations studying the sea. For many years, Dr. Aubrey, who heads coastal research at the Institute, has traveled the globe investigating changes in sea level. Can you tell whether the sea level has gone up or not over the last, say, 100 years?
No, we can't unambiguously say exactly how much the ocean has risen over the entire globe. Some tide gauge stations show the sea level rising over long periods of time. Others show sea level falling during other periods of time. The problem is that the land is also moving up and down. In some places it moves up considerably fast, in other places it falls, it subsides fairly fast. So you're measuring the sea level against another level that's moving up and down. And that leaves you with a lot of uncertainty about how much the ocean is moving versus how much land is actually moving. If you look at the British Isles, you see the same thing in a very small portion. The northern part of the British Isles, sea level is falling. South part, the sea level is rising. In the past, people have averaged different sets of tide gauge records, and they've averaged those tide gauge records for different periods of time, say from 1930 to 1960 or 1910 to 1980. And every time you take a different set of stations and a different set of dates, you can come up with whatever answer you want, in effect. I think on a time scale of the past 100 years, the errors are so great in trying to estimate what the global sea level is doing that we cannot come up with a useful answer that's going to be usable for predicting what sea level may do in the future.
We may not be able to predict what will happen in the future, but Dr. Aubrey has no doubts about the evidence so far.
There's no evidence that sea level rise has accelerated due to global warming.
While direct measurements have been unable to confirm that sea level is rising, in 1989 there appeared to be evidence of sea ice melt. When submarines passing under the North Pole reported that the ice at specific points was less deep than it had been 10 years earlier. But Julian Parron at the British Antarctic Survey is sceptical.
Just 2 snapshots of Arctic sea ice 10 years apart, even if it did indeed show a thinning, wouldn't really be significant compared with data taken from long-term monitoring of sea ice extent.
The submarine observations are contradicted by the only reliable evidence coming once again from satellites, which for the last 12 years have given us a daily picture of sea ice extent in the Arctic and Antarctic.
It says no change. It says there have been changes from year to year, but taken as a whole, you cannot say that there has been, statistically speaking, any significant change in sea ice concentration around the Antarctic.
The satellite data has only been with us since the late 1970s, but recently analysis of the amount of salt in samples of ice taken from the edge of Antarctica created from snow that has fallen over the last few hundred years, has indicated that the present levels of sea ice extent are far from exceptional.
The closer the open water is to the sites where you take your measurements, the more contaminated the ice cores become with sea salts. It's quite clear that there are periods of 5 to 10 years at a time round the Antarctic in which sea ice extent has been much less than it is today.
So, as with the sea level, changes in the amount of sea ice do not support the idea that the world is getting warmer. Not surprising, therefore, that supporters of the greenhouse effect back off the actual data under scrutiny.
What we know about the greenhouse effect is not just based on the data. The data is the ultimate way of proving that the models are right or wrong, but because of the natural variability of the system, we cannot say yes or no.
Therefore, trying to mine the record by carefully looking at every bump and wiggle, to me, is a waste of time. It's like trying to figure out the probability of a pair of dice by looking at the individual rolls. You can't look at individual rolls. You got to look at averages. So I don't put very much stock in looking at the direct evidence.
So, from the actual climate record of the Earth, from the measurements of thermometers on land to changes in sea level and ice extent, there's no convincing evidence of either a rise in temperature or an increase in sea level. The first pillar of the greenhouse theory, proof of global warming from the climate record, turns out to have no substance.
Like the first pillar, the second pillar also relies on our past evidence of the climate, but this time to support the claim that carbon dioxide causes an increase in temperature.
We know that when the Earth was 5 degrees colder 20,000 years ago, in the last ice age, that there was about 25% less carbon dioxide than during the present warm period, before the Industrial Revolution, that is. We know there was about 50% less methane. So we know that cold times tend to be associated with less greenhouse gases, warm times with more greenhouse gases.
But that's only part of the story. Our knowledge of ice age temperatures and the levels of CO2 comes once again from the analysis of the ice buried within the Antarctic plateau.
Excellent.